Ah, it's working. All right. Trig integrals. How would you integrate sine x times cosine x dx? U equals sine x. Why u equals sine x? Because the derivative is cosine. U equals sine x. Du is cosine x dx. Works out perfectly. This becomes the integral of u du, which is 1/2 u squared plus c. So the answer is 1/2 sine squared x plus c. That was an easy one. What if I gave you the integral of sine to the 8th x cosine x dx?
Is that to the 8th or to the 3?
That's an 8.
Okay.
To a 3, it wouldn't matter if it was an 8 or a 3. You'd do it the same way.
Right.
And what would you do?
Do you have to break apart the sine into
No.
minus cosine squared or something?
No, this is a u substitution problem still.
And u still u sine x.
U is still sine x because du will still be
Cosine x.
cosine x. So this simply becomes the integral of u to the 8th du. That's 1/9 u to the 9th plus c. So that's 1/9 sine to the 9th x plus c. So these trig integrals are pretty easy.
Are they really?
Pretty easy when?
They're only two terms, and they
When there's two of them,
and they're derivatives of each other.
and one of them has a power of 1. That's real nice, right? As long as you give a sine and a cosine, and one of them has a power of 1, you can let u be the other one. The derivative of sine would give you the cosine. So, what are we going to do in this section? They're both going to have powers. Then what do you do? For example, what if I give you the integral of sine to the 8th x cosine cubed x dx?
U is going to be sine cubed x.
No, you don't want u to be sine cubed x. Because think of what would happen if u is sine cubed x. Du would be, I got to use a chain rule, that would be 3 sine squared x times cosine x dx. I don't think that would help. I don't think I'd be able to substitute that sort of thing. Well, what I really wish is, I really wish that I didn't have that power 3 right there. I really wish I just had a cosine. Would it bother me if my power and my sine were bigger? Let's say the power and the sine were a 10. Would you swap? If that one could be a 10 and that one could be a 1, would you make that switch? Yes, how come?
Because the sine, what was it,
U would be sine, and that would be really easy, wouldn't it be? So that's what we're going to do. So here's what we're going to do. What you want when you're dealing with sines and cosines, you really want one of them to have an odd power. Having odd powers is a very good thing. So this is going to be the integral of sine to the 8th x. And then cosine cubed, I'm going to write it as cosine squared x times cosine x. I really want a cosine x so I can let u be sine. And then things will be very easy. What am I going to do with that cosine squared?
1 minus sine.
You use the Pythagorean identity, that's 1 minus sine squared. So that's why you want one of them to be odd. You peel off the odd one, and then you use your Pythagorean identity. So that becomes the integral of sine to the 8th x times 1 minus sine squared x cosine x dx. So you see what I was saying? Would you trade that, turn that 8 into a 10 if you could just make that a cosine x? Absolutely. Now what? Now I can do u substitution. U is sine x, and then du is cosine x dx. This becomes the integral of u to the 8th times 1 minus u squared, but then cosine x dx, all that's du. So I got rid of all those scary looking trig functions. Now what? Distribute, integrate, and you're all done. This is the integral of u to the 8th minus u to the 10 du. Integrate them. 1/9 sine to the 9th x minus 1/11 sine to the 11x plus c. So I went ahead and put my sines right back in as long as I was integrating. Simple enough to do it all in one step. Add 1 to my power, divide by my new power, plug my sines back in. Questions on that? All right, let's try another one. The integral of sine to the 5th x cosine to the 6th x dx. You look at those, and you hope one of them has an odd power. Does one of them have an odd power? Sine does. So what are you going to do? Break it up. You're going to peel off one of the signs, and eventually u is going to be, this time u is going to be cosine, because the derivative of cosine is going to give us that single sign. So we're going to write this as integral sine. We're going to peel off one sign, and then we're going to have sine to the 4th x cosine to the 6th x dx. Now we still have a problem. The problem is we still have to get rid of sine to the 4th. How do you get rid of sine to the 4th?
It's cosine squared minus 1 squared. No.
Close.
Sine squared x squared.
All right, so this is the integral of sine x. This is sine squared x squared cosine to the 6x dx. And then we use the same trick. Sine squared is 1 minus cosine squared. So you said cosine squared minus 1 whole thing squared. It should have been 1 minus cosine squared whole thing squared. So you were so very close. Although the truth is, cosine squared minus 1 squared and 1 minus cosine squared are exactly the same thing. So you were right, but not the way we normally write it. So this is going to be sine x, and then we're going to have 1 minus cosine squared x squared cosine to the 6x dx. So notice what we did. We noticed sine had an odd power, so we peeled off the one sign that left us with a sine to the 4th. Then we did a couple steps to get rid of signs and write them all in terms of cosines. And now we're ready to make our u substitution. U is cosine x. And du is therefore negative sine x dx. So we got a little minus that we got to deal with here. Oh well, we're okay. Doesn't really matter. We put it way out front. Minus integral.
Can you just do sine squared to the 3rd of the right one?
No, sine squared to the 3rd would be sine to the 6th, because when you have a power and another power, you multiply them. Good idea. It doesn't work. All right, so we've got minus. Sine x dx, oh, that's going to be du. This is 1 minus u squared squared u to the 6th du. All right, well, unfortunately, we still have a little algebra we need to do before we can integrate. What's our little bit of algebra?
We have to multiply.
You got to multiply this out, then you got to distribute by the u to the 6th, and then you integrate term by term. Not terribly hard. Minus integral. That's 1 minus 2u squared plus u to the 4th. When you take 1 minus u squared and square it, and then we still have the u to the 6th. It's minus integral u to the 6th minus 2u to the 8 plus u to the 10 du. And finally, we're in a form where we can integrate term by term, add 1 to our power, divide by our new power. Looks like our answer is negative u to the 7 over 7, but again, I'm going to go ahead and plug my cosine back in. So that's going to be cosine to the 7x over 7 minus 2 cosine to the 9 over 9 plus cosine to the 11 over 11. Let's see. Questions on that? Again, a lot of steps, a lot of work, a lot of places where it's easy to make a mistake. Once again, where's the calculus involved?
The integral.
2 spots. Spot number 1, going from there to there. And calculus is add 1 to your power, divide by your new power. Calculus is pretty easy. And there was one other step of calculus. The u sub, right there. Taking a derivative. All the rest of this is algebra and trig. So, see, students don't believe me when I say calculus is easy. Calculus is really easy. Add 1 to your power, divide by your new power. I could teach my 7-year-old to do that. It's all the algebra that you got to do to get there. That's the killer, though. The algebra is the killer.
Could you also do it like going in reverse, or do you have to start with the odd one?
Well, if one of them is odd,
Like,
this is the method you're going to go through.
well, I mean, like, could you have sine is odd? Could you do cosine? Go through it with cosine instead, or would it end up looking weird?
In this case, since this one was the odd one and this one was the even one, you have to pull out the single sign.
Okay.
If they're both odd, you can pick whichever one you like. And my general rule of thumb is if they're both odd, I pick the one with the smaller exponent. Because I don't want to have to end up dealing with something like this if I don't have to. If this were a sine to the 5th and this one were a cosine cubed,
Yeah.
I would have pulled off one cosine, taken the cosine squared, written it as 1 minus sine, and then I wouldn't have to deal with this little mess here.
Okay, that's
So if they're both odd, you can do whichever one you want. My personal thing is pick the smaller exponent.
But you can't do anything with even exponent.
Oh, no, you can do something with an even exponent. That was my next question. What do you do if both the exponents are even? Terrible, terrible things.
Do you have to do parts then?
No, you don't do integration by parts. For example, you might only just have one of them. Just a cosine squared x. What do you do? You go to your big bag of trig identities and you pull out your best one.
Do we have to turn it into tangent?
Nope. It is 1 minus sine squared x, but that wouldn't really help, would it? I mean, all that would do is change it from the problem of having a cosine squared to the problem of having a sine squared. That's not the right trig identity to pull out of the big bag this time. The right trig identity to pull out is the one that's called the power reduction formula. And I can tell by the snickers that you all remember it. The power reduction formula says cosine squared x is 1/2 times 1 plus cosine of 2x. So what does this power reduction formula do? It starts us with a cosine squared, and what's it give us? Something with a single cosine, but it does mess around with the angle. So we'll have to deal with that. There's a similar one for sine squared. That's 1/2 times 1 minus cosine 2x. Those are called the power reduction formulas.
I don't remember those.
You don't remember those?
I don't think I've ever seen them.
They're typically covered in a standard pre-calculus class. But they might not have been written that way. What you might have seen is what's called the double angle formula,
Oh,
which is cosine of 2x is two cosine squared x minus 1. That's generally called the double angle formula. Notice all I did is I took this formula here and I got the cosine squared all by itself. So written this way it's called the double angle formula. Written that way it's called the power reduction formula. Same formula, written two different ways, given two different names. Alright, so we come here and we power reduce. That's integral. 1/2 times 1 plus cosine of 2x dx, which I'm going to rewrite. That's the integral of 1/2 plus 1/2 cosine 2x dx. What's the integral of a half?
X over 2.
A half x, yeah. That was not supposed to be hard. Plus, then I'm going to have 1/2. What's the integral of cosine 2x?
Negative sine.
Two sine.
What's the integral of cosine x? The integral of cosine is positive sine.
because it's the other one.
Then what happens when you have that 2x in there? If you were taking the derivative, you'd have to multiply by 2 because you're using the chain rule. So when you're doing the antiderivative, you have to divide by 2. So this is a 1/2 sine 2x plus c. Questions on that?
Couldn't we have saved ourselves some writing by just taking out the 1/2?
Absolutely, I could have. I could have just taken this 1/2 and put it out front and then had a 1/2 with a parenthesis. Save myself some writing, sure. I chose not to, I don't know why. But.
You always use that.
Other questions?